Today, we are going to continue about the Sanjay Sky Park's construction. Until last week, we mainly dealt with the structure and load distribution of Sanjay Sky Park. Let's look at the review first. After safely finishing the three 55-story leaning building, a massive superstructure called Sanjay Sky Park was connecting the three buildings as one. We talked about how the boat-shaped structure longer than the Eiffel Tower could be kept safe at the top of the tilted building, 200 meters above the ground at the level of 55 story. Four movement zones, which can accommodate differential movements of each tower, divided the sky park into five distinct sections. More specifically, Tower 3 section had cantilever section. Three of them were directly connected to the hotel buildings, Tower 1, Tower 2, Tower 3 sections. W-shaped columns and central lift cores were connected to the hotel buildings to support each zone. Thus, the load of the tower sections was delivered to the hotel building and safely to the foundation. Next, we looked at the bridge sections. They connected between buildings and looked as if they were floating in the air. These bridge sections consist of three steel trusses, which were over 350 tons and over 50 meters long. On the trusses, cross-girder beams were placed at intervals of 4 meters. So, the load on the bridge sections was transmitted to both ends through cross-girder beams and trusses, and the transmitted load could be safely transferred to the foundation along the shear walls. And we talked about the cantilevered part in detail last time. The reason why the longest cantilevered deck in the world could be safely sustained without collapsing was the steel box girders. These heavy steel box girders were located on Tower 3, connecting the cantilever part with Tower 3. After two main steel box girders were placed on Tower 3, 6 steel box girders were connected in order, which formed cantilever. Also, columns were embedded in the main box girders. The box girders with these variable depths was connected to the hotel and carried the cantilever's load to the building to support the cantilever. We studied the components of the Sanjay Sky Park. The 6 steel box girders form cantilever section. Two main box girders connect cantilever with hotel tower on Tower 3 section, and 3 trusses form each bridge section. As such, the main frame of the Sky Park is divided into 14 segments because it was the most practical method for building Sky Park. However, all segments are hundreds of tons, and over 10,000 tons of steel structures were used to build the Sky Park. How could these heavy steel frames be lifted up to 55 story? Let's find out more about that. The Structural Steel Manufacturing Corporation was selected in Singapore. It was a local steel company, Yongnam Holdings. That company was selected as the contractor considering the ease of transport. Each steel segment was carefully prefabricated by Yongnam ENC. Since there's no room for miscalculation at 200 meters in the air, created segments were assembled on a trial basis. Then they were disassembled back into a number of segments of about 50 tons, because if it was too heavy over 50 tons, there would be a disruption to transportation. And then they were trucked to the site independently. The distance was about 35 kilometers and about 32 minutes by car. The small pieces transported to the construction site were assembled into large segments. This short clip shows how the box cutter is assembled in the field. Big but small transported pieces were welded or bolted to form one large box cutter in the site. In the same way, all 14 main steel frames were assembled next to the building on the ground. However, we already know how huge and heavy these steel frames. Cranes used in general construction sites can lift up to 20 tons. How could these steel frames, assembled at the ground level, form the sky park? Let's look at the crane installed at the top of the Marina Bay Sands hotel tower. You can see something sitting on the crane and the line coming down. If you zoom in on that part and take a closer look, you will see this following picture. There are loom for management and last, sliding pad, and strand jacking system. This strand jacking system is the key to lifting hundreds of tons of steel structures, a heavy lifting method. Let's find out about this strand jacking system. The strand jack is widely used for heavy lifting to erect bridges and other structures where the use of conventional cranes is either impractical or too expensive. The system's main components are hydraulic pumps, motive unit, and strand coiler, the tensor member, and control monitoring system. It is often used for bridge construction, like the following pictures. Look at the top of the cranes. The strand jack sits on a temporary steel structure. From this motive unit, the bundle of steel cables, called strands, go down and linked to a heavy structure. So, how can they lift hundreds of tons of structures? The strand jack is a hollow hydraulic cylinder with a set of steel cables, called strands, passing through the open center, and the bundle of strands passes through two clamps, top and bottom. Two clamps, top and bottom, are the key of heavy lifting. First, the top clamp grips the strands while the bottom clamp does not, and the strands move up almost 55 cm at one time. And the bottom clamp is tightened and locks the cables in place. At the same time, the top clamp releases the cables. And not the strand, the cylinder moves back down for the next pull-up. Top tightened, bottom released. And the cylinder moves up again. Repeat this process. This lift unit can lift heavy structures at almost 20 km per hour. From the short clip, you can see the hydraulic cylinder moving up and down and the coiler with the strand. Using this strand jacking system, hundreds of tons of skypark frames could be lifted at a height 200 meters. The strand lifting unit (SLU) used in the rear is as follows. Two SLU 330 and two SLU 120 were installed for one main box cutter, with capacity of 900 tons in total. The other three were installed with SLU 220 to lift the trusses. Considering the swaying of the wind, they had to be apart from the building more than 3 meters when they were lifted. Once the lifting is completed, sliding unit works to place the structures in place. They moved back and forth and put the structures in place. The cantilever frames, which had been test assembled on the ground, were disassembled again for lifting, and 4 SLU-70 were installed to lift each segment in order. The steel frames were placed in place through lifting and sliding using a strand jack, and the lifting information is as follows. Finally, 14 segments could be placed on top of the hotel safely. And we could complete the Sands Sky Park. Thank you for listening.